This is number 17 on page 5. This is an interesting problem also. This problem is dealing with entropy change. How is it affected by temperature? In this problem, it says that we're basically taking liquid bromine at its boiling point of negative 7.2 degrees C, and we're vaporizing it into gas. You might suspect that that's going to take energy to do that, to pull apart the liquid bonds and turn them into a more chaotic situation. You also notice the delta S here is going to be increasing. It's going to be a positive number because this is more chaotic than that. So our answer has to be a positive number. It does specify that we're at the very boiling point of bromine and that it takes 15 kilojoules per mole to vaporize bromine at that temperature. What is the change in entropy then in this case? And there is a formula that's on the front. It has the Cp, I don't even know what that means. Cp is equal to the delta H divided by degrees Kelvin. And so I've seen it written a little differently, but I'm going to call it delta S. Same thing as that, but really we're looking at the entropy. It's going to be the change in the enthalpy divided by the temperature at which you do this in degrees Kelvin. Now it's given to us in degrees Celsius, so I just want to remind you how you convert from Celsius temperatures to Kelvin temperatures. For every 1 degree Celsius you change 1 degree Kelvin. And so basically, if you have to convert from Celsius to Kelvin, you take the Celsius temperature and add 273 and you get Kelvin. And it's a very simple formula for the temperature conversion. So notice for 0 degrees C, put 0 there, I add 273, I get the Kelvin temperature. For 100 degrees C, I add a 273, I get 373 degrees Kelvin. Okay, then to answer this question, we just have to plug in the numbers really. We've got, this is the delta H per mole. And so this is for 1 mole. I'm just going to plug in that number then for the delta H. And I get this, positive 15 kilojoules per 1 mole. And I divide that by our temperature in Kelvin. Well, it's negative 7.2 degrees C. So Kelvin, that should be, if I plug in negative 7.2 here, plus 273, gives me a Kelvin temperature of 265.8 Kelvin. That is what I'm going to plug in here. And so to solve the answer, I'm going to take 15 divided by 265.8, and I get 56.4 kilojoules per degree Kelvin. And notice that's positive, which makes sense because we will have an increase in randomness. So the delta S here is going to be a positive value. And on the answer key, it's selection D.